I am repeating the last question in my previous lecture. How will you separate the mixture of ammonium chloride, sand and NaCl? Ammonium chloride is separated by sublimation. Then sand and NaCl mixture, it is dissolved in water. The sand does not dissolve in water, it is removed by filtration. Then NaCl is subjected to evaporation followed by crystallization. We will get the NaCl crystals. Then we have the question, how will you separate solid liquid mixture? Solid liquid mixture can be separated by sedimentation. The mixture is allowed to keep for some time. When solid particles they settle at bottom, they are removed by filtration, and then this mixture, it is the liquid from this mixture is decanted off. So sedimentation and decantation, these are the two techniques which are used to separate insoluble solid from the liquid. Then give some properties of metals and non-metals. So first of all, we deal with the properties of metal. They are malleable, they can be hammered into sheets. Number two, they can be drawn into wire, they are ductile, they are having good conductor of electricity, they have high density, they are generally hard except sodium, alkali metal, which are generally soft due to weak metallic bonding. They are generally solid except few metal like mercury, gallium and cesium. They have high melting and boiling point due to their strong metallic bonding. Generally they form colored compounds except the elements of first and second group. They have high tensile strength. They are sonorous. They produce nice sounds when they are struck with a hammer. And then we have the characteristics of non-metals. Non-metals, and they exist in all the three states, solid, liquid and gases. They are not malleable at all. They are not malleable at all. They are non-sonorous. They are ductile. They are not ductile. They are poor conductor of heat and electricity, and they have low densities. How the components of air they can be separated? This is our next question. The air contains major nitrogen 78.2% by volume, 20% oxygen. Along with this, it has carbon dioxide and noble gases argon, krypton, xenon, radon. So all of these gases they can be separated by fractional distillation of the liquid air. First of all, the air is liquefied, then it is subjected to fractional distillation, where we get different fractions at different temperatures. Helium, for example, its boiling point is 4.2 Kelvin, so it will be separated at 4.2 Kelvin. Then we have the argon, whose boiling point is near 80, nitrogen more than 80, then oxygen. So these gases they are collected at different levels in the fractionating column. So all the gases from the liquid air they can be separated by fractional distillation. So these are our important question. Now we will be doing some numerical problems. For numerical problem, we have to first of all read out the statement very carefully, what is given, what is asked, and how to calculate the concentration of the solutions and how to proceed for the calculations. So first of all, read out the statement of the numerical carefully. First numerical is a solution contains a solution has 16 gram of urea in 120 gram of solution. Find out mass percentage of the mixture. So what you have to find out the mass percentage of urea. To find out the mass percentage of urea, the mass of the urea divided by the total mass of the solution. If it would have been 120 gram of water, then we would have calculated the total mass of solution 120 plus 16. But in this case, it is the total mass of the solution, then nothing to be added here. You get the mass percentage of urea, that is given by 16 upon 120 multiplied by 100. This will give us the mass percentage of urea. It is 40 upon 3. This will be 13.33%. So this is the way how to calculate the mass percentage of the solute in the solution. Then we have another problem, a solution of acetone having 5 ml of it in 50 ml of its aqueous solution. Again we are given with the solution, so no need of addition here. Find the mass percentage of the acetone. So that will be our second problem. Mass or volume of acetone is 5 ml. Volume of solution is 50 ml. So we calculate volume percentage here. It is 5 upon 50 multiplied by 100. We get 10% is the mass percentage of the volume percentage of acetone in this case. Then we have the next, 10 ml of alcohol is added to water to make the volume 250 ml. Calculate the volume percentage. Again this is a total volume of solution, 10 ml of alcohol added to water to make volume 250 ml. Mass percentage of alcohol, it is given by 10 upon 250 multiplied by 100. 100 upon 25, you will be getting 4. This is the mass percentage of alcohol, volume percentage of alcohol in the solution. A solution contains 40 gram of NaCl in 320 gram of water. Calculate its concentration. Now total mass of solution is not given. 320 gram of water, 40 gram of the NaCl. In 320 gram of water. So how to calculate mass percentage? Mass percentage of NaCl will be weight of NaCl, that is 40 upon weight of NaCl plus this weight. This will be 360 multiplied by 100. You will be getting this 100 upon 9, and you will be getting 9 9 9 1 11.1% will be the mass percentage of this. Then we have the concentration of salt solution in terms of mass by mass percentage is 20%. The mass of solution is 550 grams. Determine the mass percentage, mass of the solute. Then here now you are given with the mass percentage, it is 20. 20% is given. Then we have the formula, mass of solute 100 multiplied by 100 upon mass of solvent. Now we want to calculate mass of solute in this case. Then how to proceed for that? We are given with the mass of solvent, that is mass of solution is given, rather it is 550. Then how to go for this? 550 to be multiplied, it will be mass of solute will be 20 multiplied by 550 upon 100. Zeros are cancelled, you will get 110. This will be the mass per 110 gram of solute will be present in the solution. So we can calculate mass of solute. Similarly, we can go for the mass of solvent also. Then how much mass should be added? This is a problem which is little bit different from other problems. How much mass should be added to 15 gram of salt containing 50% salt solution? 15% साल्ट सोल्यूशन पहले से मौजूद है, उसमें हमने कितना मास ऐड करना है सोल्यूट का. नाउ लेट अस डू दिस. have the question. How much solute in grams should be added to 15% solution of 15% solution of salt to obtain 15% salt solution. So let us study the problem again. How much mass should be added to 15 gram of salt to obtain 15% solution? Mass of solute, that is 15 gram. This is 15 gram. Mass percentage of solution, it is 15%. Now concentration of the solution, we know the formula. It is equal to mass of solute upon mass of solution into 100. Now let the mass of solvent is that is 15 plus x. Now we substitute the values. 15, it is equal to mass of solute 15 upon 15 plus x is the mass of solution multiplied by 100. Then we solve it 100 plus x because solvent is previously added. So now we solve it, we get 15 upon 15 multiplied by 100. This will be equal to x minus 15. So this will be equal to 100. So now we want to calculate x. X will be equal to 100 minus 15. It is 85. 85 gram of the solvent should be added to get the your amount, 15% solution of the salt. Then we have the next problem. A solution contains 15 gram of sugar in 350 gram of water. Now total weight of the solution is not given. He is saying 50 gram of sugar in 350 gram of water. To calculate the mass percentage, 50 divided by 350 plus 50, it is 400 multiplied by 100. So these zeros gone, then we have 12.5. So this is the way how to go for the problems. A sugar syrup contains 214.2 gram of sugar in 214.2 gram of syrup contains 34.2 gram of sugar. Calculate concentration of the solution. So this is another problem. 34.2 gram of sugar present in 214.2 gram of water solution. Mass percentage to be calculated, it is 34.2 upon 214.2 multiplied by 100. This is the mass percentage of sugar. So it comes out to be 15.96%. So in this manner the problems of concentration, they can be solved. We have another problem. To make a saturated solution, we know 36 gram of NaCl is dissolved in 100 gram of water at 293 Kelvin. Find out the concentration of this solution. 36 gram is NaCl, 100 gram of water. Total weight will be 136. So we can calculate the mass percentage of NaCl. 36 gram of NaCl dissolved in 200 gram of water. How much gram of water he has taken? That is 100 gram of water. 100 gram of water. Find out the mass percentage. Mass percentage of NaCl. And let it be 36 upon 100 plus 36, 136 multiplied by 100. So this will be the mass percentage of NaCl. It comes out to be 26.4%. 5%. So this is the mass percentage of NaCl. So in this manner we can go for the concentration problem. So this is all about our unit. His matter around us is for tomorrow. We'll take with another unit of 9th class, that is atoms and molecule. That is very interesting topic. You will learn it very carefully because it will again be repeated in your 11th level, 11th class. Thank you very much.